Welcome to 7.4a, Factoring Special Products. Our objective is that I can factor perfect square trinomials. So, we remember that we have perfect squares are made from a binomial or a trinomial. The whole thing, the polynomial, is squared, which means that we make two of them and we multiply them together. We'll get the first terms by multiplying the 3x times 3x. We'll get the outside, we'll get the inside, and we'll get the last terms. What we'll notice here is that when we combine, we have the same thing for the outside terms and the inside terms. We're going to use that to our advantage. We saw that earlier when we were looking at perfect squares as well. So we recall the binomials pattern. We have this 2 times a times b, which means the inner term will be 2 times whatever is for a times whatever it is for b. And the same thing for the minus case over here, where we have a minus 2 times a times b, and that's the way that it will be. I have a feeling that we're going to try some normally, and then we'll see if we can use the patterns later on. So for normal factoring for these guys, 9x squared could be 9x and x. It can be 3x and 3x. This 4 can be 1 and 4, or 2 and 2. The middle term is positive. All the terms are positive, so I don't need to worry about these negatives case. We can just leave them off completely. So 9x times 1 plus x times 4. Well, that's 9x plus 4x, which is 13x, which is not 12x. Let's try 9x times 4 plus x times 1. That'll give me 36x plus x. That's 37x, which is not 12x either. So we're looking for the one that'll give us 12x. So next we're going to try 2 and 2. 9x times 2 plus x times 2. And I only have to check this one time, because if I swap the 2 and the 2, it'll just be the same. So I'll have 18x plus 2x, that'll be equal to 20x, which is not 12x, so that's not what we want. Which means we're totally done with this 9x and x case. We are only looking at the 3x and the 3x. 3x times 1 plus 3x times 4. These ones are nice because I only have to check them once each as well. 3x times 1 is 3x. 3x times 4 is 12x. And 3x plus 12x is 15x, which is close but not quite what we want. So we know that it's going to be this 2 and 2. Let's just double check and make sure. So we'll have 3x times 2 plus 3x times 2. 3x times 2 is 6x. 3x times 2 is 6x. And when I add them together, I'll get 12x, which is what I want. Awesome. So now I know what needs to be inside my parentheses. Inside my parentheses needs to be 3x plus 2 and 3x plus 2. And we have the two of the same thing. We're just going to make the whole thing squared. That's what our answer is going to be. Now that we've tried one, go ahead and pause the video and try this one on your own, and I'll see you in a second. Now that you've done it on your own, let's do it together. So I have 4x squared plus 12x plus 9, which is similar to the last one. My factors of 4x squared are 4x and x, and 2x and 2x. My factors of 9 are 1 and 9, and 3 and 3. Okay, 4x times 1 plus x times 9. That'll be 4x plus 9x, which is 13x. Okay, how about 4x times 9 plus x times 1? That's going to be 36x plus 1x is 37x. And that's not even close to 12x, so we don't want those ones. So now we've eliminated about half of that 4x and x case. Okay, let's try 4x 3 plus x times 3. 4x times 3 is 12x. X times 3 is 3x. Add those together and I'll get 15x, which is not what I want. So we're all done with that 4x times x case. So we know, since it's the only other option, that it must be 2x times 2x. So 2x times 1 plus 2x times 9. That's 2x plus 18x, which adds up to 20x. So it's not going to be that one. Although I could, even if I swap them, they'd just be the same since I'm just multiplying by 2x each time. So let's try the 3 and 3. 2x times 3 plus 2x times 3. That's going to be 6x plus 6x, which does add up to 12x. Awesome. So I now know what needs to be inside my parentheses. It's going to be 2x plus 3 times 2x plus 3. And I can simplify that. Since I have two things of the same thing, I'll just have it be once inside the parenthesis, but I'll have it be squared. Okay, this time, let's try looking for perfect squares and trying them first. So 81y squared, that's 81y times y. Also, it's 9y times 9y. So let's try that one first. And 16, that's 1 and 16, 2 and 8, and 4 and 4. But let's try checking the 9y and the 4 first. 9y times 4 plus 9y times 4. That's going to be 36y plus 36y. That's, 72y. Okay, we've got the same thing, but it's negative. Let's try switching the signs of both of those. If I switch the signs of the 4's, that'll mean now I have minus 36y plus a negative 36y. And that's going to become negative 72y, which is what I want. So remember, when the two outside terms are positive, but the inner one is negative, that means that both of these terms are going to be negative when we're all said and done. So that means that we have 9y minus 4 times 9y minus 4. And we have two parentheses that are the same, so I'm going to combine them together by sticking a square on the outside of that parenthesis. And that's going to be our answer. Go ahead and pause the video and try it on your own. Now that you've tried it on your own, let's do it together. Once again, let's try looking for that perfect square. So you tried it on your own. We saw that the middle one's negative, but the outer ones are positive, which means both of these over here are going to be negative. So we're going to try them out. Times negative 9 plus 4z times negative 9 minus 36z plus minus 36z. That's equal to negative 72z, which is great, which means that we're going to have 4z minus 9 times 4z minus 9, and combine those together into one parenthesis, not minus 19, just regular 9 squared. There we go. But how do we know? How do we know? Well, we have to ask ourselves, are the first and last terms perfect squares? Yeah, they are for this case, right? 3x times 3x will give me 9x squared, and 5 times 5 will give me 25. So, is the middle term 2 times a times b? 2 times whatever we use to multiply to get our perfect square, times the other thing we use to multiply to get our perfect square. So we have to check. 2 times 3x is 6x. 6x times 5 is 30x. But 30x isn't 50x, so it doesn't fit the pattern. So we can come up with a new method that will still simplify our lives a lot. It's called the AC method. It's for when the two edges are perfect squares. So here's what we need to do. Notice that 9 times 25, so my coefficients equal 225, and we want to find two things that multiply to give us 225 that add up to give us our middle term, 50. So then we can split up that middle term and factor by grouping, which is really nice. So let's try it out. It's kind of a new thing. So first we need to check and see if our middle terms, our first and last terms, are perfect squares. So this will be 4r times 4r. So yes, it is a perfect square. 3s squared can be multiplied 3s times 3s. So it is a perfect square. Is our middle term 2 times a times b? So is it 2 times 4r times 3s? 2 times 4r is 8r. 8r times 3s is 24rs. So no, it's not. We've fallen short, which means we need to use the AC method. So I'm going to go back though. So what we need to do is we need to say, well, let's do this. Let's figure out what the terms need to add up to. So 16 times 9. 16 times 9. When I pull out my calculator, 16 times 9 is 144. So I want to split up 24 into two things. I want to split up 144, excuse me, of two things that add up to 30. So I can do that 1 and 144. 2 and 72. Those don't add up. Let's see if I can do 3. 144 divided by 3 is 48. But those don't add up to 30. How about 4? 4 and 36. Those don't add up to 30. How about, it's not going to go into 5. What about 6? 6 and 24 do add up to 30. So that's what we're going to use. We're going to use them to add up to 30. So now we're going to factor by grouping. So I'm going to rewrite this 6r squared plus, and I'm going to rewrite it as the ones we found, 6rs plus 24rs plus 9s squared. I'm going to see what I can factor out of each side. Looks like I can take out an r, and I can also take out a 2. That'll give me 8r plus 3s. Then on this side, let's see what I can take out. Looks like I can take out a 3 and an s. So let's do that. 3s times 8r plus 3s. And now when I factor by grouping, what do they have in common? Put right there, and then I put the leftovers. 2r plus 3s. And I'm done. There we go. That was quick and painless for the most part. Go ahead and try it on your own, and then we'll do it together. Now that we've done it together, let's do it. Or excuse me, now that you've done it, let's do it together. So, do I have two things that can be multiplied to give me 9u squared? Yeah, 3u and 3u. Do I have two things that can multiply to give me 100? Yep, 10 and 10. So they are perfect squares. Is the middle term 2 times a times b? 2 times 3u times 10 is 60u. And 60u is not 87u, which means we're going to use the AC method. So we need to multiply the two outer ones. 9 times 100 is 900. And I need to split them up until they're 87. So let's see if I can get closer to 87. So I can do 1 and 900. I can do 2 and 450. I can do 3 and 300. I can do 4 and 225. I can do 5 and 180. I can do 6 and 150. How about 7? I don't think so, but I'll try it out. 900 divided by 7. Nope. How about 8? Nope. How about 9? Of course. 9 and 100. 10 and 90. We're getting closer. I'm going to jump down and try 45. It's going to be 20 and 45, but that's not enough, so it's got to be somewhere in between. How about 15? Let's try 15. 15 and 60, we're getting close. That adds up to 75. So we need a few more. How about 913? How about 912? 900 divided by 12 is 75, which is what we want. It's going to be 12 and 75, and then we can factor by grouping. So I'm going to rewrite it. 12u plus 75u plus 100. And I'm going to factor by grouping. So here I'm going to take out a 3u times 3u plus 4. And I'm going to take out a 25. That'll give me 3u plus 4. Now I can factor by grouping. 3u plus 4 times 3u plus 25. And I'm done. Thanks for watching. I'll see you in the next video.